All right, so this is another one where we need the calculator. You can see that from the decimal answers. A person whose height is 6 feet is walking away from the base of a streetlight along a straight path at a rate of 4 feet per second. If the height of the streetlight is 15 feet, so we can label the height as 15 feet for the streetlight and 6 feet for the person. We're assuming neither of them are changing. What is the rate at which the person's shadow is lengthening? Okay, so here's how shadows work, except I can't draw, okay? This is a triangle, right? The light hits the person's head, it casts a shadow. That's how it works. That's the tip of your shadow. Right. So we want to know how fast the person's shadow is lengthening, right? So I'm going to call this S for shadow, this length S for shadow. The nice thing about shadows is they create similar triangles. So I don't know what this angle is, but I don't really have to know. What I know is that the red triangle that I have here between the person and the shadow and this little chunk here has to be similar to the very large green triangle that I will create here, because they both share this angle. And I'm going to call this measurement, I'm going to call this little measurement x. So what I get is that there's this big green triangle with a 15 and an x plus s, and and that's similar to a little red triangle with a 6 and an s, but they're similar, right? So what similarity means is that 15 is to x plus s, and my s's always look like 5s, which I hate, but it is what it is. That's equal to a 6 over s, which means I can cross multiply and clean this up. I can say 15s equals 6x plus 6s, or 9s equals 6x, right? Meaning, if I differentiate, so if this is my equation, if I differentiate my equation, 9 ds dt, the rate at which the shadow is lengthening, equals 6 dx dt. Well, dx dt is how fast this guy's moving, right? Because dx dt is how fast he's walking, and we were given that. The guy is walking away at 4 feet per second. So dx dt is 4 feet per second, which means I can now find ds dt by saying ds dt is 6/9 times dx dt, right? Or 2/3 times a 4 in feet per second. And I guess, again, totally forgot this was a calculator problem because I totally did all the work by hand, but it's 8/3, which is going to be this guy right here, right? So we should get B. Here, this was one where the calculator actually wasn't particularly useful. You could certainly use it to simplify your numbers, but that was about it.